How continents moved over millions of years. Have you ever wondered if the continents you see today were always where they are? At first glance, the Earth seems like a stable, unmoving sphere, but a closer look reveals the opposite. Over millions of years, continents have drifted, broken apart, and collided to create the map we know today. This is the fascinating story of Earth's moving continents, a story that not only helps explain our planet's past, but also sheds light on its present and future. Let's embark on this journey to uncover how continents moved over millions of years and why that matters. About 200 million years ago, Earth looked vastly different. All the land on the planet was fused into a colossal landmass scientists call Pangaea. This supercontinent dominated Earth's geography, surrounded by a vast ocean called Panthalassa. Pangaea wasn't just a theoretical concept. Evidence supporting its existence comes from matching fossils found on distant continents, identical mountain ranges split by oceans, and even the geological composition of rocks. For instance, fossils of identical ancient reptiles, such as Mesosaurus, have been discovered in both South America and Africa, despite the vast Atlantic Ocean separating these continents today. This led scientists to the revolutionary idea that continents were once joined, debunking the millennia-old belief that Earth's land masses were forever immovable. But how did Pangaea break apart and evolve into the continents we see today? To answer that, we must look deep into the Earth, beneath its crust, to uncover the dynamic forces driving this transformation. At the heart of continental movement is a scientific phenomenon known as plate tectonics. Earth's surface is broken into massive slabs of rock, called tectonic plates, that fit together like an intricate puzzle. These plates aren't static. Instead, they float atop Earth's semi-liquid mantle, a layer of molten rock lying beneath the crust. The movement is fueled by convection currents in this mantle, where heat rises from the Earth's core and pushes the plates. Think of it like a giant conveyor belt. Plates are constantly created at mid-ocean ridges, where molten rock wells up and pushes the seafloor apart, a process called seafloor spreading. At the same time, plates are destroyed in subduction zones, where one plate dives beneath another and sinks back into the mantle. The forces of plate tectonics shape more than just the continents. They influence the geography of the entire planet, creating mountain ranges, ocean trenches, islands, and even volcanic arcs. But their most visible legacy is how they've carved and rearranged Earth's continents over millions of years. So, how exactly do continents drift? The process begins with seafloor spreading, which pushes plates apart at certain boundaries. One of the most famous examples is the Mid-Atlantic Ridge, where the Atlantic Ocean continues to grow as the Americas drift away from Europe and Africa. On the other hand, collisions between plates can create towering mountain ranges like the Himalayas, formed when the Indian subcontinent rammed into the Eurasian plate. Sometimes, plates slip past one another along fault lines, causing earthquakes. The San Andreas Fault in California is a stark reminder of how dynamic Earth's crust can be. Other times, plates pull apart, creating rift valleys that can eventually become new ocean basins. The journey doesn't stop there. Over millions of years, these movements have transformed Earth's layout. From the breakup of Pangaea came smaller supercontinents like Laurasia and Gondwana, which fragmented further into today's continents. These landmasses, perched on their tectonic plates, continue their slow yet relentless drift to this day. How did scientists uncover the truth behind moving continents? The answer lies in a wealth of evidence that transformed plate tectonics from a hypothesis to an accepted scientific theory. Fossils, rocks, and even magnetic forces tell the story. For instance, fossils of ancient plants like Glossopteris, found across South America, Africa, Antarctica, and Australia, hint that these continents were once connected. Matching geological features, such as continuous mountain chains split by oceans, further reinforce this idea. One of the most intriguing pieces of evidence comes from the ocean floor. As molten lava rises at mid-ocean ridges and solidifies, it records the direction of Earth's magnetic field. These magnetic stripes alternate in polarity on either side of the ridge, providing a symmetric pattern that confirms seafloor spreading. This discovery cemented the understanding of ocean floor movement and the drift of continents. The movement of continents hasn't just shaped the Earth's geography, it has transformed ecosystems, climate, and life itself. As landmasses drift, they carry ecosystems with them, altering habitats and influencing biodiversity. For instance, the separation of South America and Africa led to the evolution of unique species on both continents, a pattern seen throughout Earth's history. Continental drift also plays a role in climate. Shifting landmasses change ocean currents and atmospheric patterns, influencing global temperatures and weather systems. Imagine the difference between continents clustered near the equator versus those near the poles. These shifts have caused ice ages, warm periods, and countless environmental changes over Earth's history. Plate tectonics isn't just a relic of Earth's past, it's happening right now, reshaping the world beneath our feet. Regions like the Pacific Ring of Fire are hotspots for tectonic activity, causing frequent earthquakes and volcanic eruptions. For instance, Japan and California are prime examples of areas shaped and often threatened by active tectonic boundaries. Scientists have even predicted where our continents might drift millions of years into the future. Some speculate that a new supercontinent, called Pangaea Proxima or Amasia, could form as the Atlantic Ocean closes and continents converge once again. These predictions remind us that Earth is constantly evolving, even if the changes occur too slowly for us to witness in a single lifetime. Understanding plate tectonics is more than just a fascinating story of Earth's history. It's a tool for understanding the present and preparing for the future. By studying tectonic movements, scientists can better predict earthquakes, tsunamis, and volcanic eruptions, helping communities prepare for natural disasters. Knowledge of tectonics also explains the distribution of natural resources, like the oil and minerals we rely on, which are influenced by ancient plate movements. Beyond practicality, learning about plate tectonics deepens our appreciation for the dynamic and interconnected systems at work on our planet. It encourages us to marvel at the forces that have shaped mountains, oceans, and continents, and to respect the delicate balance that sustains life on Earth. Where will our continents end up millions of years from now? Although we can't know for sure, current plate movements point to fascinating possibilities. The Atlantic Ocean may continue to widen, pushing the Americas further away from Europe and Africa. Meanwhile, the Pacific Ocean could shrink as its tectonic plates are subducted. Perhaps in another 200 million years, the continents will merge again into a new supercontinent, only to break apart once more. These slow yet monumental changes remind us that Earth is alive, constantly reshaping itself in ways we are only beginning to understand. They also challenge us to think long-term, beyond human lifetimes, to consider the legacy we leave on this vibrant, dynamic planet. The story of how continents moved over millions of years is a reminder that Earth is far from static. From the colossal supercontinent of Pangaea to the scattered lands we see today, the forces driving plate tectonics have shaped not only our planet's geography, but also its climate, biodiversity, and future. Understanding these processes gives us a glimpse into the inner workings of our miraculous world. It's a story of incredible power, patience, and transformation. A story that continues to shape life on Earth today. So the next time you glance at a map, remember, the continents beneath your feet are not still. They're part of an ancient journey that began billions of years ago and continues to this very moment.